On today's episode, will SpaceX take over the NASA Space Launch System? This episode of This Week in Engineering is brought to you by the American Society of Mechanical Engineers. Learn more about how the Society promotes the art, science, and practice of multidisciplinary engineering and allied sciences around the world at asme.org. From an engineering perspective, the most impressive thing about NASA's greatest achievement, the Apollo program, was the gigantic Saturn V rocket. Building a system 365 feet tall to launch an entire lunar spacecraft in a single throw was technically ambitious and audacious. It was big because it had to be, as dictated by physics, and today the return to the moon programmed by NASA through the Artemis project involves a similarly giant launch vehicle, the Space Launch System. Everything about the Space Launch System is impressive. Its Block 2 iteration will be capable of lifting over 280,000 pounds into low Earth orbit, and it's powered by 4 shuttle-derived RS-25 engines, generating 2 million pounds of thrust. Off the pad, these will be supplemented by 2 solid rocket boosters, which will contribute an additional 7 million pounds of thrust. Much of the Space Launch System technology is derived from the Space Shuttle program, including engines and solid rocket boosters, and the solid rockets will be recovered and reused as they were in the shuttle program. The main stage fuel is liquid hydrogen and the traditional liquid oxygen oxidizer. Upper stages will also use developed versions of legacy engines, notably the RL-10, originally developed by Pratt & Whitney in the late 1950s. The original Saturn V was a collaborative effort between NASA and the aerospace industry, and the Space Launch System is no different. Prime contractors are Boeing, Northrop Grumman, Aerojet Rocketdyne, Lockheed Martin, United Launch Alliance, and NASA's own Marshall Space Flight Center. Saturn V had no pier and heavy lift to low Earth orbit, but this time it's different. Elon Musk's SpaceX is currently preparing the 7th test flight of their Starship, an even larger launch vehicle with surprisingly similar performance. Its Super Heavy booster is configured differently with clustered Raptor engines developed in-house at SpaceX, burning liquid methane and liquid oxygen. Throw weight to low Earth orbit is reported at 100 tons. The second stage of the system is currently the Starship Orbiter, which is designed for a powered descent and soft landing after re-entry. Both are intended to be reusable after refueling and refurbishment. 2 heavy lift launch systems with both intended to send crewed spacecraft beyond Earth orbit. The NASA system was designed from the outset for exploration, with no published plans to turn the system into a commercial vehicle. This may not even be possible with program costs for the entire lunar exploration now exceeding $100 billion, over a program life extending for decades. Full reusability of the SpaceX system promises much lower launch costs, although the full development costs of Starship and the Super Heavy booster are unknown since it's a private development. And like the NASA system, to date there have been no commercial applications for this basic launch vehicle, although the Department of Defense is interested in the possibility of delivering troops and cargo over long distances. Both systems are overkill for commercial satellite launch, although SpaceX will use some test flights to deploy in-house Starlink satellites. SpaceX has also secured a contract from NASA to develop and launch the crewed lunar lander for the Artemis program, so both launch vehicles will be part of the return to lunar exploration. But an increasingly vocal online community is questioning the rationale for the NASA system at all, given its extremely high costs. Driven by the experience of the space agency after the Columbia disaster, NASA has declared an intention to develop 2 or more parallel systems for crewed spaceflight to provide redundancy. And the Artemis program uses major contractors which represent every major player in the American aerospace industry. Maintaining spaceflight technology development industry-wide has been a secondary goal of NASA spaceflight for years, and SpaceX is unusual in that the firm does not rely on major contractors for significant portions of their hardware. But if SpaceX can demonstrate heavy lift to low Earth orbit at a fraction of the cost of the NASA system, pressure to go all in with that system will be likely, given Musk's cost reduction advisory role in the incoming administration. From an engineering perspective, however, Artemis has demonstrated propulsion to escape velocity with circumlunar flight, while Starship has not yet demonstrated orbital capability, although this is expected in 2025. The stakes are enormous, and lobbying efforts from established aerospace firms will be intense. Could NASA conceivably put all its eggs in the SpaceX basket? Time and Trump will tell.